Alright, this is Unit 7, Video 3. It's a continuation of the law of sines, and this is on what I call the Jack case, otherwise known as the ambiguous case. Make sure that you have your Video 3 note sheet ready. So the law of sines, this is a review, is used to determine the measures of the missing sides and angles of an oblique or a non-right triangle. In the Video 1, we discussed what to do if we were given one side and two angles. In this video, we will discuss what to do when we are given two sides and an angle that is not between them. So this would look like SSA, which is why I call it the Jack case. So I'm going to draw a couple pictures here to demonstrate why we're going to end up with three possible outcomes here. If we're given two sides of a triangle, side B and side A, and we're given an angle that's not between them, so let's suppose we're given angle A down here, side A may be too short, so we would have no such triangle. In another situation, side A, same picture here, but side A could have the same distance just be put into two situations, making this kind of an equilateral triangle. However, I'm looking for the larger triangle here, or this triangle highlighted here. In this case, we will have two possible triangles, and we will be solving for both. In the simplest situation, A will have exactly one perfect value, and there will be only one option. So I'm going to talk you through three different possible situations, and I'm going to give you an example of all of them so you can see how these will turn out. Example 1 can also be found on page 298. It is example number 5. I'm going to be drawing the triangle from the beginning with you. So go ahead and draw on your paper triangle ABC. It doesn't matter what it looks like. And label your vertices A, B, and C. And remember that the side little a is opposite angle A, and the side little b is opposite angle B. I'm going to go ahead, and because I have the possibility of two different outcomes, two different possible triangles here, depending on the missing side measure, I'm going to go ahead and draw two answer boxes. Angle A, B, C, and side A, B, C. And I'll repeat that, A, B, C, A, B, C. And I know that angle A is 95 degrees in both situations. And I know that little a is 50 in both situations. And that little b is 26 in both situations. So that information is already given to me. Now I'm going to choose a different color here to really highlight the fact that we are looking at two sides and an angle that is not between them. So this does give us our side-side angle. And I'll be looking for both angles B and C, and then side little c. We're going to use the law of sines to do this, so I'm going to set it up with the information I do know. And that is that little a over the sine of angle A, so 50 over the sine of 95, will equal 26 over the sine of angle B. Now in the previous video, we were given the angle, but we had to find the sine. So this time we're going to have to do a little bit different work. I'm going to enter in my calculator 26 times the sine of 95, and then I'm going to divide that by 50. Make sure you close your parentheses if you're using extra parentheses, or just hit enter and then divide by 50. This is going to give us the sine of B. But I need to find angle B, so we will have to use sine inverse of the answer. That's how we're going to find angle B. Go ahead and do that now. I come up with 31.20 degrees. You must now go ahead and take 180 minus angle B from the first example to come up with the second possible situation. The reason is the sine is equal to its supplementary angles have the same sine value. So I'm going to use supplementary angles, or 180 minus the current angle, and I will find that they both have the same sine value. So now I'm going to take 180 minus the 31.2, and I get 148.8 degrees. Okay, so let's continue. To find the missing angle that's left here in my first triangle on the left-hand side, I'm going to take 180, subtract 31.20 and 95, and I come up with the third angle being 53.8 degrees. All right, now on the other side here, if I do 95, if I do 180 minus 95 minus 148.8, I notice that this angle comes out to be a negative 63.8 degrees. So this triangle, the second possibility, didn't turn out because my angle measures were too large for a second possible triangle. All I have left to do now is to complete this and find the missing angle measure, or missing side measure, C. So I will start with the first given information because it is fact and I didn't do any rounding on this piece. And then I will have little c over the sine of 53.8, which is my angle C. And this will be entered as 50 times the sine of 53.8. Hit enter and then divide by the sine of 95, and that will give you little c. I come up with little c to be 40.5. All right, just to recap on that one, after I found angle B from my first step here, I went ahead and found its supplementary angle. This allows me to find the second possible case for our triangles. I came up with an angle that's 148 degrees, but because the given angle in the original problem was 95, these angles were too large to form a triangle, and so therefore this second possible triangle didn't exist. I just continued then and found the last piece of the original triangle. All right, let's go ahead and do the second one here. Again, I'm going to draw the triangle out using the information given. Doesn't matter where you label anything. And I'm going to draw for the possibility of two triangles. So I have angle A, B, and C, and little a, B, and C. I'm going to put in the information that I know to be fact into both situations. All right, now I'm left to set up my first law of sine ratio, and that is that 26 over the sine of 48 will equal 31 over the sine of angle A, because that's opposite angle A. I'm going to use the inverse button after I've done the cross multiplication in order to find the measure for angle A. Remember, taking an inverse of a value actually finds the angle measure that we're looking for. I come up here with angle A to be 62.38 degrees. In order to find the second possibility, I'm going to take 180 and subtract 62.38 degrees. It's not a very good color. And that's my second possibility for angle A, 117.62 degrees. I'm going to use the triangle sum theorem to add these up and subtract from 180 to find the missing angle. I'll do that on both sides of my situation. So on the first side, on the left-hand column, 180 minus 62.38 minus 48 gives me a third angle of 69.62 degrees. On the other side, 180 minus 117.62 minus 48 gives me an angle measure of 14.38 degrees. This means that two possible triangles exist because these angles are allowed they do sum to 180 degrees. On the left-hand side here, I have to find the missing C value that works with this particular given information. I'm going to use the 26 over the sine of 48 degrees as the foundation for what I'm going to work with, and then I'm looking for little c to be the sine of over the sine of 69.62 degrees. On the other side, I'm going to set up something similar, but I'm going to use the angle 14.38 degrees. Okay, so I'm going to go ahead and calculate those now and find the other two C values. For this side, I come up with 32.80 degrees, and on this side, I get 8.69. Oops, I put degrees. That should just be a unit of measurement there, not degrees. Okay, now, as we go ahead and look through this one, we realized that we ended up with two possible triangles, which means that the side angle A could either be 62 degrees, a very small angle, or it could be 117 degrees, making angle C very small. So my picture is definitely not doing these triangles justice, and if we need to draw them in class, we can. Lastly, you should definitely measure and double check the angles against the side measurements. The largest angle should have the largest side across from it. So on my right hand side, 117 is the angle measure for angle A, and the largest side should be across, whereas the smallest measure, 14.38 degrees, should be across from the smallest side measure. This is true in all triangles. That's a good way to double check to see if you've paired them up correctly. We've got one more example to try together. Example 3 is page 298, number 9. For this one, I'm going to go ahead and draw a triangle again and label it. And I'm going to make out my information here on the side as if I'm preparing for two possible triangles. The reason I'm doing two possible triangles again is because I have two sides given and the angle that is not between them. That gives us our side, oops, that's not an S. That gives us our side-side angle. All right, fill in the information that is fact for both of them. So I have 58 degrees for angle A, little a is 50, and little b is 61. Okay, with that much information given, I'm ready to go ahead and find angle B because it matches the missing angle up here. So I will have 50 over the sine of 58 degrees will equal 61 over the sine of angle B. So if I use my cross multiplication, I'll have 61 times the sine of 58 degrees divided by 50, and I'll take the sine inverse. What you'll notice is you come up with a domain error. If you go back to the screen before that and you notice that what you're taking the sine of, I lost it on my screen, is you're taking the sine inverse of 1.03, and the problem with that is that there's no value where sine is going to be greater than 1. if you think back to our graph, sine is never greater than 1. So therefore, this will always come up with a problem. I cannot fit a value in there to get my sine inverse to work. That means that not only is there not a second triangle, but there isn't even a first triangle. These values do not lead us to any possible triangle. So in this case, you would write no such triangle. All right, recap. When do you test for a second triangle? You are always going to check for a second triangle in the jack case. You will find a second triangle when the new second found angle that's kind of complicated to understand, but when the new second found angle completes 180 degrees. So you have to check the triangle sum to equal 180 degrees. That's the only time there's going to be a second triangle. When no triangle exists. Well, no triangles are going to exist if you're taking the sine inverse of a value that is greater than 1. It will never work. You will never find that value because this is not within its domain. So remember, anytime you're given a jack case, you have to look for that second possibility.